Right, two triangles are said to be similar if their corresponding angles are congruent and their corresponding sides are proportional. Um, so what we're looking for here is to look at the sides and angles of our two figures, and this doesn't necessarily need to be for triangles. It could be for any sort of shape. If their angles are congruent, or any polygon, right? If their angles are congruent, um, and their corresponding angles are congruent, and their sides are proportional, we know that they are going to be similar. Okay, so similar triangles mean that they have the same shape, but different sizes. So they look the same, it's just that one is a bigger or smaller version of the other one. All right, so first thing here, we have our triangle symbol. So we have triangle UVW. So here's triangle UVW. And we have triangle XYZ. And we're saying they're similar. So we're using this symbol here. Let's go a little bigger. Using this symbol here to denote that they are similar. That little tilde tells us they are similar. So we know that these two triangles are similar. All right, so their angles are congruent. So their corresponding angles here. So angle W here, this angle W, is going to be congruent to angle Z. So the arcs here represent that those two angles are the same size. Right? Angle U is congruent to angle X. So there's two arcs here. That signifies that these two angles are congruent. And then angle V is congruent to angle Y. So that's going to denote that these two angles are going to be congruent. All right, so if, for example, congruent means that their measures are the same. So for example, if Z was 35 degrees, W would also be 35 degrees. If Y was 90 degrees, right, that would tell us that V is also 90 degrees. And since the three angles of a triangle have to add up to 180, our last angle here would have to be 55 degrees. And so if angle X is 55 degrees, then U is also 55 degrees. Okay, so angles are congruent. Okay, and then sides are proportional. So we've talked about proportions. Proportions are ratios that are equal. So the ratios we're looking at are the corresponding sides. UV, the ratio of UV to XY, right? That ratio is going to be equal to the ratio of UW and XZ, and that's going to be equal to the ratio of VW and ZY. So let's look at this and solve for our missing sides. So that's what we want to do here is we want to solve for the missing sides of this triangle. So I'm going to call this one X and I'm going to call this one Y. So we're going to solve for those two values. Okay, well, we know that UV is 3. So we're going to plug that in, substitute that in here. So we're at 3 over 12. Okay, XY, that's this length here. XY is 12. UW is going to be 5. XZ is going to be X. Okay, VW is going to be 4. And then ZY is going to be Y. Okay, so what we're going to do here is we're going to pick two of our ratios. They're all equal, so we can pick any two we want. So I'm going to pick the first two here. Okay, so 3 over 12 and 5 over X. Okay, and we already did this to solve for X here. When we have a proportion, we're going to cross multiply. So we're going to do 3X equals 5 times 12. Okay, that's going to be 3X equals, so that's 60. Divide by 3. Right, and we're going to get X equals 20. Okay, so 3 over 12 is going to equal X over 20. All right, and then we can do the same thing with Y. Let's pick, let me use a different color. Okay, but let's use these two. All right, so we're going to do 3 over 12 equals 4 over Y. All Right? So we cross multiply, we're going to get 3y equals 12 times 4. So 3y equals 12 times 4. It's going to give us 3y equals 48. If we divide by 3, so let me back up a step here. Divide by 3, divide by 3. We're going to end up with y equals, that's going to be 16. 3 is going to go into 48 16 times. So we know y is going to be 16. Right, so if we look at our ratios here, we have, if I do it in a different color, we have 3 over 12. Right, we have 5 over 20, 5 over 20. We found x to be 20, so 5 over 20. Okay, and then we have 4 over 16. Okay, if we reduce all of these, 3 divided by 12, we're going to get 1/4. Let me maybe write it a little smaller. Okay, if we reduce 5 over 20, we're going to get 1/4. And if we reduce 4 over 16, we're going to get 1/4. So we see here that the ratio of the corresponding sides are all equal, right? So that's why they're proportional. So for similar figures, this is what our side ratios are going to look like. They should all be equal. Okay, the proportions, the ratios are equal. So sides are proportional, right? Sides are proportional. And then the other piece here where our angles were congruent. So we have congruent angles, meaning they have the same measure, and then corresponding sides are proportional.